All right, guys, we're finishing the note sheet from Friday. Got a note sheet? You're good. So we are starting off with, where did we finish up? With subtraction or multiplication? Okay, so we're right here. Yes. So the next one we're looking at is product. F times G of X. F times G of X is equal to F of X times G of X. We're multiplying the two together. Now, so F times G of X is F of X. Did we not finish? Where did we get to? Sounds good. We'll finish that up first. So F of X, F minus G of X. We'll finish this one first. All right. 4x squared minus 8x plus 4 minus 3x cubed minus 5x squared plus 6x minus 9. And on Friday, we dropped the parentheses of the first and nothing changed. The second, we had to distribute the negative through. Getting us to this point here. Now, this is where we stopped or ran out of time. So the next thing we had to do in this here is combine like terms. So I always start with the variable with the biggest exponent. So our cubics. So we have 2x cubed minus 3x cubed. 2 minus 3 is going to be negative 1. So negative 1x cubed or just negative x cubed. Then we'll do our square terms next. 4x squared plus 5x squared. 4 plus 5 is going to be 9x squared. Then we'll have our x terms, negative 8x minus 6x. Negative 14x. And lastly, 4 plus 9 is plus 13. So f minus g of x gives us negative x cubed plus 9x squared minus 14x plus 13. So that's the equation. Now we need to evaluate it when x is negative 1. So once we find this equation, we're going to replace every x in it with negative 1. Now at this point here, we can type the whole thing in the calculator. Negative parentheses, negative 1, close parentheses, cubed, plus 9 times negative 1 squared, minus 14 times negative 1 plus 13. Over plus 9 times 1 squared. And then, no, it's not plus, minus 14. Plus 13. Type it all in and we see that it is 37. Questions on this here? Nothing. That's it. Oh, yeah. Questions on any of this here? We ready for the next one? So, product. We're going to be multiplying these two together. So f of x is equal to x squared, and g of x is equal to the square root of x. We want to find the product, f times g of x. We're not going to worry about the domain, but if we were to try to find the domain, we look at the domains of each. X squared's domain is all real numbers. We can plug any value of it into x. The square root of x, on the other hand, we cannot plug in a negative number into a square root and have a real number. So the domain for the square root of x is all values of x greater than or equal to 0. So the domain of the product is going to be all the values of x greater than or equal to 0. Now, when we multiply this together, we'll replace f of x with its function, which is x squared. G of x is the square root of x. We're multiplying x squared and the square root of x together, which is x squared times the square root of x. And this is as far as we're going to take it, because we could actually multiply these two together. But in order to do that, we need to rewrite the square root of x as a rational exponent. Because it depends on if we got to that or if y'all got to that in Algebra 1, but it is possible to rewrite it as a fractional exponent. But for us here, we're just going to leave it. If it starts off in radical form, leave it in radical form. Now, it also wanted us to evaluate this when x is 9. So we would need to figure out what 9 squared times the square root of 9 is. 9 squared is 81. Square root of 9 is 3. Which would be 243. Questions on how we found the product or evaluated this when it's 9? All right, guys, focus in. Now, if we were dividing and it gave us the radical, we can leave, for this here, we can just leave the radical on bottom. We don't have to rewrite it. Because if we divided this, you don't have to write this, because we'd have x squared over the square root of x. Normally, we would have to rationalize the denominator. We cannot leave a radical in the bottom of a fraction. But for this here, what we're covering before spring break, we'll leave it as this. When we come back to it, the rest of chapter 5, we will have to rationalize that denominator. We cannot leave a radical in the bottom of a fraction. And the only reason I've seen or come across is that we don't want to leave an irrational number on the bottom of a fraction. Because the square root of x could be an actual nice number, especially if x is 4, 9, 16, 25, perfect square. Any other number, we have a non-repeating, non-terminating decimal in the bottom of a fraction. We don't want to leave that. But let's look at products. All right, guys. Let f of x equal x cubed and g of x equal the square root of x. We want to find f times g of x and then evaluate it when x is equal to 4. First thing I'm going to do is replace f of x with its equation x cubed, g of x with the square root of x. Since one of them is in radical form and the other is in exponential form, we'll just multiply them together, put them next to each other, and get that f times g of x is x cubed times square root of x. Then we need to evaluate this when x is 4. So we're going to have 4 cubed times square root of 4. We can plug this into the calculator and it'll tell us that it is 128. Because 4 cubed is 64. And we multiply it by the square root of 4, which is 2. 64 times 2 gives us 128. That's up. Any other questions on this? Here. Be ready for the next part. Division, dividing our quotient. F divided by g of x. So when we divide, we're going to have f of x divided by g of x. So f of x is told to us to be 6x. G of x is x to the 3/4. Now we could put the parentheses around the top and bottom, but because there's no other terms outside of f of x and g of x, we just drop the parentheses and get to the same spot. Questions on how we got here? We good to this point? Yes. Now, if they had written that denominator g of x in radical form, written it as a radical, our square roots, cube roots, fourth roots, we'd leave it at this here. When we come back to it, we'll go about and go back over how to rationalize denominators, especially if we have radicals that aren't just square roots, cube roots, fourth roots, fifth roots. But here, they didn't put the denominator as a radical. So we can actually simplify this because we are dividing like bases. Because we have x on top and bottom, they're being divided. Whenever we divide like bases, we subtract the exponents. Now, even though they didn't write it, the exponent on top is 1. Exponent on bottom is 3/4. So I'm writing it out here so we can kind of see what we're doing, because for the most part, up to this point, we've divided like bases with integer numbers, whole numbers. Even though it's fractional, same process still holds true. We're doing 1 minus 3/4. And 1 minus 3/4 is 1/4. So it's telling us f divided by g of x is 6x to the 1/4. Because they gave it into us, or gave it to us in a form that we can actually divide, simplify this nicely, we're going to go on and do it. The other radicals, we could have done this, but we'd have to change that square root into a fractional exponent and then subtract. So here, make sure I get the right number, 16. One-fourth power. Really all it's saying, what times itself 4 times is 16. Which is 2. Or we can plug in 6 times 16 to the 1/4, which is 12. Questions on how we found f divided by g of x, or how we evaluate it when x is 16? We good with this here? We ready for the next one? Let f of x equal 4x and g of x equal x to the 2/3. Find f divided by g of x. F of x divided by g of x. F of x is 4x, g of x is x to the 2/3, so we have 4x over x to the 2/3. Since we're dividing like bases, we will subtract the exponents. So it tells me that I have 4 times x to the 1 minus 2/3. Now, if there was a number in front of x on the bottom of the fraction, we would divide those coefficients 4 by whatever's on the bottom. If it reduces, if it simplifies, simplify it. If it doesn't, leave it in fractional form. 1 minus 2/3 is going to be 1/3. Telling us that f divided by g of x is 4x to the 1/3. Now we just need to evaluate this when x is 27. Bless you. So we're going to replace x with 27, so we have 4 times 27 to the 1/3, which incidentally enough is 12 also. All right, guys, focus in. Questions. We good with all this so far? Last 2, we're going to look at this one, well, 3 more. We're going to look at 1 more with addition, subtraction, 1 more with multiplication, division. And then we're going to look at actually how we can do these, find values in the calculator. All right, guys, focus in. Focus in. F plus g of x is our f of x plus g of x. So we're adding the 2 functions together. F of x for us here is negative 2x to the 2/3. G of x is 7x to the 2/3. Since we're adding, we can go on and drop those parentheses, and it's still just negative 2x to the 2/3 plus 7x to the 2/3. Now, our variable expressions in both are the same. They're both x to the 2/3, which means we can add those coefficients. So negative 2 plus 7 is 5x to the 2/3. Now we will need to evaluate f plus g of 8. We need to evaluate the sum when x is 8, but we'll go on and find the subtraction, the difference first. So for our difference, f of x minus g of x, we plug in f of x as negative 2x to the 2/3. G of x is 7x to the 2/3. And when we simplify our parentheses, we get negative 2x to the 2/3 minus 7x to the 2/3. Negative 2 minus 7 is negative 9x to the 2/3. Questions on how we found our sum or difference? Now we just need to evaluate them both when x is 8. So for our sum, all right, guys, we have 5 times 8 to the 2/3. And again, at this point, I'd grab the calculator, let it do it for us. And 5 times 8 to the 2/3 is going to be 20. All right, guys. f minus g of 8 would be negative 9 times 8 to the 2/3. Again, we can grab the calculator, say negative 9 times 8 to the 2/3 is negative 36. So 5x to the 2/3, and when we evaluated, we got 20. For our difference, we have negative 9x to the 2/3, and when we evaluated it, we got negative 36. Questions on this here? Let f of x be 3x and g of x be x to the 1/5. Find f times g of x and f divided by g of x. The domain we're not so much focused on, but for our product it would be all real numbers. For the division, our quotient, it would be all real numbers except 0. Now for our product, f of x times g of x, well, f of x is 3x. G of x is x to the 1/5. Now, unlike the last ones, with our product, they actually gave us one of the two expressions in not radical form. So we have x and x to the 1/5. Whenever we multiply like bases, we add the exponents. So for us here, our x times x to the 1/5 would be x to the 1 plus 1/5, which is actually going to be x to the 6/5. Now the 3 is multiplying with the number in front of x, which would be 3 times 1, which is just 3. Question? You asking about where we got the exponents? Or the numbers? Why it stayed 3 and not changed? Yeah. So what we're doing is we're adding like bases. So we're going to add the 1 and 1/5. So to actually add them, the denominators have to be the same. So we're turning 1 into 5/5. Then 5/5 plus 1/5, the 5 and 1 on top would make 6. Mm-hmm. All right, guys. Focus in, focus in. So our product, f times g of x, is 3 times x to the 6/5. For our quotient, f divided by g of x would be f of x over g of x. F of x is 3x. So we have 3x over x to the 1/5. Since we do have like bases that are being divided, we're going to subtract the exponents. So it's going to be x to the 1 minus 1/5. So we would subtract them. Now the nice thing with these here is that the exponent for x on top is bigger than the denominator, because 1's going to be bigger than 1/5. So when we subtract 1 minus 1/5, we're going to get 4/5. So it's telling us that f divided by g of x is 3x to the 4/5. Questions on any of this so far?
How do you know if you plus or minus
The exponents?
Yeah.
So the way that we know if we need to add or subtract is what operation is being done. When we multiply like bases, according to our exponent property, because a to the n times a to the m is a to the m plus n. Whenever we multiply like bases, we add the exponents. Because we're saying that I have this n of them, and I'm multiplying by m more, so total, we have those combined. Because if this is 2, and I'm multiplying it by 3, well, I have 2 and 3 more gives me a total of 5, because 2 plus 3 is 5. And if we divide a to the n over a to the m, is a to the n minus m, because they're simplifying on top and bottom. Because however many we have on bottom will simplify with that many on top. Now, if the denominator's exponent's bigger, when we do the subtraction, it would be negative. That's why in previous lessons we've talked about if it's bigger on top, it stays on top. If it's bigger on bottom, it's going to stay on bottom. Because if I stick with the same numbers as before, a to the 2 over a to the 3, I'll move. We would have a to the 2 minus 3, which would be negative 1. To make it positive, we'd have to move it from the top of the fraction to the bottom. Or we say 3 minus 2, since it's bigger on bottom, it's going to stay on bottom. Kind of deal. We're used to this, but because we throw those fractional exponents, it makes us think that there's something different we need to do. Same properties still hold true. It's just that we get fractional exponents. Does that make sense? Okay. All right. Any other questions before we start evaluating? So when x is 32, we're saying 3 times 32 to the 6/5. And again, I just grab the calculator, say 3 parentheses 32 to the 6/5. And it tells us it is 190. We'll do the same thing with f divided by g of x. So 3 times 32 to the 4/5. 3 times 32 is questions on any of this here? Questions on anything we've done so far? We ready for the last part? Let f of x be the square root of x and let g of x be the square root of 9 minus x squared. Use a graphing calculator to evaluate f plus g of x, f minus g of x, f times g of x, and f divided by g of x. You're going to need a graphing calculator. Yep. You're going to need one. Go on and grab one. Yeah. Okay. So, first thing you need to do is turn the graphing calculator on. So, luckily, this is going to be helpful to know, especially there's applications we can use outside of this. You're not going to have to do this on the assignment. But, first thing you're going to want to do is hit y equals. We want to put f of x and g of x into their own function. So we can put f of x into y1. So f of x is the square root of x, so we go second, get our square root x. we'll put g of x into y2. Second square root 9 minus x squared. So second, and then down where x squared is, or the x2. Yep. So, oh, if you want x right there. Mm-hmm. No, I think you're. Now hit that one. There we go. Enter. Now plug the g of x in. Mm-hmm. The square root, or x, right x to alpha, or squared, or the same button you did for square root.
Oh, I don't know why.
You're good. Was everybody able to get both equations in?
I might just
Y equals.
having a stroke right now. What's that?
There you go. Second. Yep. 9 minus x squared. We got them both typed in. Second quit. Second quit. We want to go back to the home page, the main screen. Second quit, once you get them typed in. Once you get them both typed in, second quit, second mode. Now you're good. Mode. Right next to. So, all right, guys, focus in, focus in. So what we want to do is find the sum of f of x and g of x when x is 2. Now, there's two ways to do it. One is I go second graph and find where x is 2, look at the two y values and add those together. That's not what we're going to do. What we want to do is hit alpha, trace, and you should get this list of y1 to y0. Now, we're going to hit enter to select y1. Parentheses 2, close parentheses. Because what this has told us, and what we're telling the calculator to do, is take the equation y1 and plug 2 in for x. And we want to add to it, because that's f of x. Now g of x, we're going to go alpha trace, and we want to select y2. And hit enter. Then we'll go parentheses 2, close parentheses. So what we're telling it to do is to take 2 and plug it into y1 and find that value, and plug 2 into y2, find that value, and add those two values together. Once you get both of those typed in, hit enter. And that's the value of it. So it asks us to round to 2 decimal places, so 3.65. So we will do multiplication eventually, but we get this here. Questions on this? Now, the reason I said that y'all can use this, especially going forward, on the ACT, especially when it says evaluate for the given value or which of the following values is a solution, and especially if they already have it equal to 0, we can plug that equation into y1 and go y1, put that number in, hit enter, see what it tells us. If it's equal to 0, it's a solution. If not, we can easily just replace that again and again and again, and it's a lot faster than having to retype the entire equation out every single time. Now, it also wanted us to subtract. So we're going to do the exact same thing, but this time, instead of adding, we're going to subtract. We get negative 0.82. Then it asks us to multiply next. Now we can do the exact same thing, alpha y1, or alpha trace y1, plug our number in, so on and so forth. Or once we get it plugged in once, use the arrow key and go up and select it or have it selected and hit enter. So it brings it right back down because we can bring any of the previous equations down. It works on both calculators. And then we can go over and change it from subtraction to multiplication. Questions on this here? But that's it. That's